Good afternoon, all, and you are welcome to today's class. Please permit me to. Sorry for not taking you last week. I think I have issue with my laptop, so I have to borrow someone's laptop even to do this class. Then another thing is the study section 5. That is regression and correlation. Maybe I will send that one later because I've already prepared the recording, the slide, and everything before my laptop pack off. So if I'm able to get the laptop back, I will try and send it to the MLS. So today we are on study section 6, unit 1, and our topic is estimation. What are the objectives of this study unit? The objective of this unit are to enable students to understand the fundamental concept of statistical estimation and its roles in inference, distinguish between point estimation and interval estimation of population parameters, learn the desirable properties of a good estimator such as biasness, consistency, and efficiency, exploit different methods of estimation including the method of moment and maximum likelihood estimation, construct and interpret confidence interval for population means and proportion, and also understand the relationship between estimation and hypothesis testing in statistical inference. Build a foundation for conducting and interpreting hypothesis tests based on sample and data. What are the learning outcomes for study section 6, unit 1? By the end of this unit, students should be able to 1. Define and explain the concept of point estimation and interval estimation. That is, what is point estimation all about and what interval estimation is all about. We should be able to differentiate and when to use point estimation and interval estimation. The second learning outcome is to identify and describe the properties of a good estimator, which includes unbiasedness, consistency, and efficiency. What do we mean by all this? When do we say an estimator is unbiased, or when do we say an estimator is consistent, or when do we say an estimator is efficient? Another learning outcome is to apply different methods of estimations, as in different method of estimating estimation, such as the method of moment, the method of likelihood. How we can apply it to obtain parameter estimate. Also, we should be able to construct and interpret confidence interval for population parameter, mean and proportion at specified confidence level. We should explain the link that exists between estimation and hypothesis testing within statistical inference. Also, we should use estimation techniques to make informed decisions based on the sample data and solve practical problems in business, economics, and social sciences using appropriate estimation. Introduction. Estimation and hypothesis testing. Estimation and hypothesis testing are foundational concepts in statistics and are widely used in economics, businesses, social sciences, medicine, engineering, in every discipline. These techniques are used to make inference and draw conclusions about population based on sample. We use this estimation and hypothesis study instead of considering the whole population. We draw our conclusion and we make inferences based on the sample. I think I've told us the difference between sample and the population. Like in a class, let me say in your ODL class of 200 level students, ODLC, we can take some people as a sample, like maybe we select 5 boys, 5 girls. We can base our inferences, we can make inferences and draw a conclusion based on the sample we took from the class instead of considering the whole population. Estimation. Estimation also involves the process of estimating unknown population parameter using sample data. Estimation involves the process of estimating unknown population parameter when we use sample data. What are the goals? The goal is to provide an approximate value for a parameter of interest such as the mean or proportion, along with a measure of uncertainty or confidence associated with the estimate. A point estimation. Point estimation provides a single value estimate That is point estimation. It provides a single value estimate, while interval estimation provides range of values within which the parameter is likely to fall. Interval estimation provides a range of value within which the parameter is likely to fall. The parameter that we want to estimate is likely to fall, while point estimation is just like a single value estimate, while parameter estimation provides a range of value within which the parameter that we want to estimate is likely to fall. On the other hand, hypothesis testing is a procedure for making decision or drawing conclusion about a population based on the sample data. How do we do hypothesis testing? Hypothesis testing procedure is used for making decision. We can use it to make inference, to draw our inference, to make decision, or to draw conclusion about population based on the sample data. A good estimator should have desirable properties such as unbiasedness, consistency, efficiency, sufficiency, etc. And various methods of estimation are used in practice. Such method includes method of moment. We have method of maximum likelihood estimation, which is now in statistics we rarely know the true population parameter. What are those examples? What are those true population parameter? They include the mu, which is our mean. I've once told us about mean. Our variance, which is our sigma scale, or proportion, which is our p. Instead, we collect data from a sample and use it to make inference about the population. That is, from the whole population we can select samples and we use that sample to make inferences and conclusion about the whole population. Then two key tools in statistical inference, they are estimation and hypothesis. Now let's talk about estimation. What is estimation? Estimation is a value assigned to a population parameter based on the value of the statistics. Let me repeat myself again. Estimation is a value assigned to a population parameter based on the value of the statistics. It provides the best possible values for unknown parameter. Estimation provides, or let me say estimate. Estimate provide the best possible values for unknown parameter. An estimator is a sample statistics used to estimate population parameter. Like that, your mean is a sample statistics that is used to estimate population parameter. Example of our population parameter are like our mean or mu, our variance sigma square, or proportion p. An estimator is a sample statistics used to estimate a population parameter, and I've listed our population parameter like our mean, our variance, and our proportion. And there are two types of estimator. We have a point estimator and an interval estimator. What is a point estimator? A point estimator is a single statistics computed from sample data that provide the best guess for an unknown population parameter. What is a point estimator? A point estimator is a single statistics computed from sample data that provide the best guess for an unknown population parameter. Example, our sample mean x bar, which I once told us that our x bar is summation of xi over n. I think when we are in a study section 2, unit 1 or unit 2 thereabout. So our sample mean x bar is the estimate of population mean mu. Our sample proportion p cap is the estimate of population proportion p. Our sample variance s square is the estimate of the population variance sigma square. 2. An interval estimator. An interval estimator provides a range of values within which the unknown parameter is expected to lie within a certain level of confidence. It consists of two numerical values. within which we believe with some degree of confidence, including the value of the parameter being estimated. It falls within a specifying within a range of values on which we can assert with a certain degree of confidence that the population parameter will fall within the interval. The confidence that we have a population parameter theta will fall within confidence interval is 1 minus alpha, where our alpha is the probability that the interval does not contain theta. Here, from this diagram, assuming we have the population variance sigma square, which is known, and the population is normal, because this is a normal distribution. It has a bell shape. With one side we have alpha, which is our alpha level of signal divided by 2, and the other one. So the first one is half, the second one is half. We have our mu, and the inside the bell shape we have 1 minus c, which is our confidence interval. Assume the population variance sigma square is known and the population is normal, then 100 into brackets 1 minus alpha percent. Now an example, assuming we want to construct a 95% confidence interval for mu, for a standard normal distribution, we can use our x bar. I have told us that our x bar is summation of xi over n plus or minus, that is the range, z alpha over 2 sigma over root n, where our z alpha over 2 is the critical value from the standard normal distribution. Z alpha over 2 is the critical value from the standard normal distribution, and our sigma over root n, I think I've told us that we can compute our sigma when we're doing our study section 2. Our sigma, which is variance, is over root n is the standard error. It implies that there is a 95% confidence that the true mean lies within the calculated interval. Then we have various properties of an estimator. The first one is an estimator should be unbiased. What do we mean when we say an estimator is unbiased? An estimator theta is said to be unbiased if the expected value of theta is equal to the population parameter theta. That is, E of theta, expected value of theta cap, is equal to the population parameter theta. If the expected value after taking the expectation of theta cap is equal to the population parameter theta, we say such an estimator is unbiased. Another one, efficiency. The most efficient estimator among a group of unbiased estimator is the one with the smallest variance. Any estimator among the most efficient estimator is any estimator among a group of unbiased estimator with the smallest variance. Such estimator is said to be efficient. Is the most efficient, and it is refers to the sampling variability of an estimator. Another property is sufficiency. An estimator is sufficient if it uses all the information from that a sample can provide about the population parameter, and no other estimate can provide additional information. Let me come again. Sufficiency. An estimator is sufficient if it uses all the information that a sample can provide about a population. It uses all the information that the samples can provide about the population parameter, and no other estimate can provide additional information. Then we have consistency. An estimator is consistent if, as the sample size becomes larger, the probability increases that the estimate will approach the true value of the population parameter. What are the methods of finding an estimator? We have different methods, but we'll consider these three. We have method of maximum likelihood, MLE. We have method of moments, and we have expectation maximization algorithm. Now, example. An experiment was created out to sample the average, to estimate the average number of heartbeats per minute for a certain population. Under the condition of the experiment, the average number of hearts per minute for 49 subjects were found to be 130. If average, that is our X bar, if it is reasonable to assume that 49 patients constitute a random sample, the population is normally distributed with a standard deviation of 10. From these questions, our n has been given, our standard deviation has been given, and our X bar average has been given. They said we should determine A, the 90% confidence interval for mu, 95% confidence interval for mu, and 99% confidence interval for mu. So we are using the formula X bar because our X bar has been given, our n has been given, our sigma has been given. So X bar plus or minus Z alpha over 2 sigma over root n. What is our X bar? Our X bar is 130, our n is 149, our sigma is 10. Then our alpha, for the first one we are using 90%. 1 minus alpha, which is equal to our alpha is 0.90. So alpha is, when you take away 1 minus 0.90, our alpha is 0.1. Then your alpha divided by 2 will be 0.91 over 2, which will give you 0.05. Let me come back again. Our X bar is 130, our n is 149, our sigma is 10. Then our, for the first one they said 90% confidence interval, our 90 will be, our alpha is 0.9. when you convert 90 to decimal, 90% when you convert it, it will give you 0.9. then to get your alpha, 1 minus alpha, which is 1 minus 0.90, it will give you 0.01. then your alpha over 2 is 0.01 over 2, which is equal to 0.05. now using the formula X bar plus or minus Z alpha over 2 sigma over root n, since we have all our parameters, we fixed our X bar, which is 130, plus or minus Z alpha over 2. We've already estimated our Z alpha over 2 to be 0.05. Then sigma, our sigma is 10 over root n. What is our n? Our n is 49. Our n is 49, not 149. Our n is 49. So 130 plus or minus Z alpha over 2, 10 over root 49. 130 plus or minus, we've already estimated our alpha over 2 to be 0.05. That is 1 minus alpha over 2. We've already estimated that one to be 0.05. Then 10. What is the root of 49? That will give us 7. So we have our 130 plus or minus 1.645. Then when you divide this, you check this from a standard normal table. That is why that is where we get our 1.645. We are using from our statistical table. We go to our standard normal table and we check for Z at 0.05. That will give us 1.645. Then 10 divided by 7 is giving us 1.43. Maybe when you come for the physical class, I will tell us how we can get the Z 0.05. But it's very simple. Just take your statistical table, open standard normal, check the table of contents, you see standard normal, check at Z 0.05, it will give you 1.645. Then 10 over 7 is giving us 1.43. Now 130 plus or minus, when you multiply this, 1.645 times 1.43, it will give you 2.35. Now 30 plus or minus 2.35, so it will be 30 plus 30 minus 2.35. That will give us 127.65. 130 minus 2.35, that will give us 127.65, comma 130 plus 2.35, that will give us 132.35. That is for 90% confidence interval. Then we do for 95. When our alpha is 95, then that will change to 0.95. 1 minus 0.95, then you divide it by 2. That will give you 0.025. So x bar, you will use the formula again. X bar plus or minus z alpha over 2 sigma over root n. That will be 130 plus or minus 0.025, then 1.43 from our previous, that is 10 over 7. Therefore, since we are doing statistics, it's better you learn the something just the way you do the first one, the way you did the first one, do the second one like that. Don't try to shorten all these things, because we mark steps in statistics. The steps, we follow steps in marking. So please, when you see it in either test or exam, 0 points, write your formula, then follow the procedure for the first one. But the only difference is, instead of using 90%, here you are using 95%. Let it be explicit. Then we do for the other ones too. So when the population variance is unknown, the distribution used for constructing confidence interval for mu is the T distribution. Please take note of it. When the population variance is unknown, the distribution that we used for constructing confidence interval for mu is the T distribution. Please take note of this. So the difference between the distribution that we are using, when to use standard normal and when to use student T distribution. So we use student T distribution when the population variance is unknown. The distribution for constructing confidence interval for mu is the T distribution. Here, an estimate S must be calculated from the sample to substitute for unknown standard deviation. T distribution is also based on population and is normal. A 100 into bracket 1 minus alpha % confidence interval for mu when sigma is unknown is given by, we use this formula, x bar plus or minus c alpha over 2 instead of using z alpha over 2 for known population variance. Now for unknown population variance, we use c alpha over 2, x bar plus or minus c alpha over 2 n minus 1 s over root n, where our n is less than 30. Where our n is less than 30. When our n is less than 30. Now an example, a sample 25 teenager old boys yielded a mean weight and standard deviation of 73 and 10. Their mean weight is 73, their standard deviation is 10, and their n is 25 pounds respectively. Assuming a normal distributed population, find 90% confidence interval, 99% confidence interval for mu of the population. From here now, our x bar, which is 73, at times they can give you your x bar in values and ask you to compute the x bar. They ask you to compute the standard deviation. So our x bar here is 73. By now we should know how to compute x bar and s. Our x bar is 73, our n is 25, our s is 10, our alpha for the first one 90%, so 0.9, 1 minus 0.9, that will give us 0.1. Then alpha over 2, 0.1 divided by 2, that will give us 0.05. Then that will be, then we apply our formula, x bar, which is 73 plus or minus t 0.05 comma n, because from the formula we said t alpha over 2, what is our n? N minus 1. So 0.05 comma 25, 10 over root 25. Then we check for t 0.05 at n in our statistical table. That one will give us 1.71. Then 10 over root 25, our root 25 is 5, 10 divided by 5, that will give us 2. So we check that, then we multiply 1.71 times 2, that will give us 73 plus or minus 3.42. So the first one will be 73 minus 3.42, or comma 73 plus 3.42. Then we do for 90 and I think 99% confidence interval. Confidence interval for population proportion, we did that one for mean. Then here we have confidence interval for a population proportion. To estimate a population proportion, when estimating a population mean, a sample is drawn from the population of interest and the sample proportion P bar is completed. The sample proportion is used as the point estimator of the population proportion. Assume normally population when MP and n into bracket 1 minus P is greater than 5, so that our P bar is equal to Z alpha over 2. That is the formula we are using to compute population proportion. Please listen o. Our P bar is, which is our population proportion, is equal to Z alpha over 2 sigma Z alpha over 2 root P bar into bracket 1 minus 3 over n, where our P bar, how to estimate our P bar is x over n. Thanks for